Tesla has been making the impossible happen in the past years. In the next years, it might shock us even more when they finally complete their first ever hoverboard that will definitely take the automotive industry literally to the next level. Would you buy a Tesla hoverboard once it hits the market? The possibility of a Tesla hoverboard. The idea of a Tesla hoverboard has been a subject of speculation and fascination for many years. After all, when we think of futuristic technology and Elon Musk's ventures, we often imagine flying cars, self-driving vehicles, and innovative modes of transportation that push the boundaries of what's possible. Musk himself has hinted at bold and futuristic ideas, so the idea of a Tesla hoverboard doesn't seem that far-fetched. Let's take a detailed look at the possibility of Tesla creating a hoverboard, including what the technology could look like, the challenges that would need to be overcome, and why this could be something we might see in the future. Tesla, under the leadership of Elon Musk, has become synonymous with groundbreaking innovation. From electric cars that challenge the automotive industry's norms to solar products that change how we think about energy, Tesla is always looking toward the future. When we think about the possibility of a hoverboard, it's easy to imagine this idea fitting perfectly with Tesla's ethos of pushing boundaries and embracing futuristic technologies. Musk has made no secret of his interest in innovation, and if you look at the various projects he's involved in, like SpaceX's plans for Mars exploration, the Boring Company's tunnels, or Neuralink's brain-machine interfaces, it's clear he's thinking beyond the usual scope. Tesla, while known for its electric vehicles, could use its expertise in battery technology, propulsion systems, and advanced engineering to create a truly unique hoverboard. What would it look like? If Tesla were to create a hoverboard, we'd likely see something that blends the sleek design of their cars with futuristic technology. Tesla has always prioritized clean, minimalist aesthetics, and it's safe to assume that their hoverboard would be no different. The sleek, aerodynamic look of a Tesla vehicle could easily translate into a smooth and attractive design for a hoverboard. The most significant challenge would be the propulsion system. Traditional hoverboards use gyroscopes and small motors to give the illusion of levitation, but these hoverboards don't truly hover in the way we envision in science fiction. For a true hoverboard, like those seen in movies, such as Back to the Future Part 2, we'd need to see levitation technology that allows the board to float above the ground. Tesla could potentially harness its expertise in battery technology to power the hoverboard, using the same advanced lithium-ion batteries found in Tesla vehicles. To actually make the hoverboard hover, a form of magnetic levitation, maglev, or advanced air cushion technology would likely be needed. Maglev technology, which uses powerful magnets to repel the board from the ground, has already been used in high-speed trains, but applying this technology to a personal transportation device would require overcoming a host of engineering challenges, including miniaturization and cost. So, why would Tesla want to venture into the hoverboard market? Beyond the obvious appeal of creating a fun, futuristic product, a Tesla hoverboard could serve as a marketing tool for the company, showcasing its cutting-edge technology in a whole new light. Tesla has always been about pushing the envelope in innovation, and launching a hoverboard could be the next step in their effort to redefine personal transportation. Additionally, the hoverboard market could cater to a niche group of consumers. With the growing demand for eco-friendly, sustainable transportation options, a Tesla hoverboard powered by clean energy could align well with the company's environmental goals. It could offer a new mode of transport for short-distance travel, especially in urban environments where traditional vehicles might be less practical. While we may not see a Tesla hoverboard anytime soon, the idea is certainly in line with the direction that transportation technologies are headed. Electric scooters, bikes, and cars are already making waves as alternatives to traditional vehicles, and as battery technology and propulsion systems continue to improve, it's not too far-fetched to imagine the possibility of a hoverboard-style device in the future. Elon Musk has often teased out-of-the-box ideas, so a Tesla hoverboard could be on the horizon as part of the company's long-term vision. With Tesla's innovative spirit and focus on high-tech solutions, it's exciting to think about the ways the company could revolutionize personal transportation, whether it's through a flying car, a self-driving bike, or, who knows, maybe even a true hoverboard. While a Tesla hoverboard is not a product that exists today, the idea is not entirely out of reach. Tesla's history of groundbreaking innovation makes it clear that they're not afraid to dream big. And with advancements in battery technology, magnetic levitation, and electric propulsion, a future Tesla hoverboard could very well be a reality. For now, though, we'll have to settle for daydreaming about zipping around on a Tesla-powered hoverboard, perhaps in the not-so-distant future. The challenging obstacles of the Tesla hoverboard. While the dream of a hovering personal vehicle is exciting, there are significant technological and logistical hurdles to overcome. Magnetic levitation, maglev, is one of the most promising technologies for creating a true hoverboard, a device that can float above the ground without making contact. Imagine the thrill of zipping through the streets, gliding effortlessly above the pavement, with no friction slowing you down. While it sounds like something straight out of science fiction, maglev technology has already been used in high-speed trains and is, in theory, capable of revolutionizing personal transportation in the form of a hoverboard. However, as with many cutting-edge technologies, there are significant challenges that must be addressed before maglev can become a practical and viable solution for personal transportation devices like hoverboards. Magnetic levitation relies on the principle of using magnetic fields to lift and propel an object, essentially eliminating friction with the surface beneath it. There are two primary methods used for magnetic levitation: electromagnetic suspension, EMS, and electrodynamic suspension, EDS. Both technologies make use of magnets to either lift the object or provide thrust, allowing it to hover above the ground. Electromagnetic suspension, EMS. This method uses strong electromagnets beneath the object, which are controlled by a feedback system. These electromagnets create a magnetic field that repels the object from the surface, keeping it suspended. This is the method currently used in maglev trains, which use powerful electromagnets embedded in the track and the train itself to levitate and travel at high speeds. Electrodynamic suspension, EDS. This method relies on superconducting magnets and the interaction between magnetic fields to lift and stabilize the object. While this technology is more advanced, it typically requires cooling the magnets to very low temperatures, which can make it more expensive and complex to implement. While both systems can create the illusion of hovering, they still require specific conditions, including carefully designed tracks or surfaces. This is where the biggest challenges lie in trying to bring maglev technology into the realm of personal transportation, such as with hoverboards. For maglev technology to work effectively, it often requires specialized infrastructure. In the case of high-speed maglev trains, the tracks are designed with a precise configuration of magnets, which interact with magnets in the train to provide lift and thrust. This is what enables the train to glide over the track at high speeds without friction. However, the same infrastructure is not available on most streets or pavements, which poses a significant challenge for implementing maglev hoverboards. If a Tesla, or any company, were to develop a hoverboard using maglev technology, it would need to overcome the issue of creating a levitation system that works on regular roads and sidewalks. Currently, roads are not magnetized, and they don't have the specialized infrastructure needed to support magnetic levitation. For a true hoverboard to function, a system of magnets would have to be embedded in the ground itself, a process that would require significant investment in infrastructure. Furthermore, the magnets used in maglev technology need to be extremely powerful to support the weight of a person on a hoverboard. This presents another challenge. How do you create a compact and powerful magnetic system that can work in everyday environments without making the hoverboard impractical or too expensive? This is where current maglev technology faces a bottleneck. Surface preparation. The most immediate obstacle for maglev hoverboards is that the surfaces we walk or ride on are not designed to accommodate magnetic levitation. As it stands, maglev trains are only capable of operating on specially constructed tracks. This would make it incredibly difficult, if not impossible, to design a hoverboard that could work on everyday streets. To enable hoverboards to function on regular streets, cities would need to invest heavily in creating magnetized roads or specialized pavement that would support such devices, an investment that is unlikely to happen in the near future. Maglev systems rely on electromagnets that require a constant supply of electricity. In the case of trains, these systems are typically powered by an external source. Another challenge that arises when dealing with maglev for personal transport is the safety aspect. The cost of developing a viable maglev hoverboard would be astronomical. As mentioned earlier, maglev technology requires powerful magnets, complex control systems, and precise engineering, all of which come at a high price. Tesla has a long history of pushing the boundaries of technology, particularly in the field of electric vehicles and energy storage. While the company has yet to venture into maglev technology specifically, it's not out of the realm of possibility that Tesla could apply its expertise in electric propulsion, battery technology, and design to create a hoverboard. Musk's involvement with other futuristic ventures, such as the Boring Company and SpaceX, shows that he is not afraid to take risks and explore new frontiers. Tesla's battery technology, which is one of the most advanced in the world, could potentially be used to power a maglev hoverboard. Additionally, Tesla has already demonstrated its ability to design innovative, high-performance products, such as the electric cars and the upcoming Cybertruck. This expertise could give Tesla a unique advantage in overcoming some of the technical barriers of maglev hoverboards. However, Tesla would still face the same challenges as any other company trying to create a mass-market hoverboard: power, infrastructure, safety, and cost. While Tesla could push the boundaries of technology to make this vision a reality, it would require significant advances in maglev technology and a major rethinking of how we design and build cities for transportation. That was maglev alone. Then there's the challenge of power supply. Is the Hoverboard project a nearly impossible feat for Tesla? Yes, the idea of a Tesla-powered hoverboard sounds like something straight out of science fiction. However, one of the most important aspects of making this vision a reality is the power supply. While Tesla has already revolutionized the electric car industry with its remarkable advancements in battery technology, applying these innovations to a hoverboard presents a unique set of challenges. A hoverboard, by its nature, requires a compact and efficient battery that can provide enough power for propulsion, all while being light enough to maintain the board's portability and practicality. Unlike electric cars, which have ample space to house large batteries, a hoverboard is a much smaller device. This means that every aspect of the battery, from its size to its weight and power output, must be optimized to fit within the limited space available. The battery needs to deliver enough energy to keep the hoverboard in motion, but without turning the device into an impractical, bulky object that would be difficult to carry or ride. It's a delicate balance between power, weight, and efficiency, and achieving this balance is one of the major hurdles in designing a Tesla hoverboard. To understand the complexity, it's helpful to consider the battery technology used in Tesla's electric vehicles. Tesla vehicles, such as the Model S and Model 3, use large, high-capacity lithium-ion battery packs. These battery packs are specifically designed for high energy density, which allows the cars to travel long distances without needing to recharge frequently. However, scaling down this technology to fit into a hoverboard presents a challenge. The hoverboard would require a battery that can maintain sufficient energy output for propulsion while also being small and lightweight enough to keep the device practical for everyday use. For a hoverboard to function as a practical mode of transportation, it needs enough power to propel the rider over a variety of surfaces, including smooth pavement, streets, and possibly even slightly uneven terrain. Tesla's existing battery technology is optimized for high-performance vehicles, but a hoverboard requires a different kind of power, one that focuses on efficient, sustained output rather than quick bursts of energy. The hoverboard's battery would need to be capable of maintaining power for extended periods without the need for frequent recharges. This means that the battery must not only have a high energy density, but also an efficient system for managing that power. This is where Tesla's experience in energy management, which helps electric cars optimize their range and performance, could play a major role in hoverboard development. Tesla's sophisticated software and battery management systems could be adapted to ensure that the hoverboard's power is distributed efficiently, maximizing the battery's lifespan while providing the necessary power for a smooth ride. One of the defining features of a hoverboard is its portability. Imagine trying to ride a heavy, cumbersome device that requires more strength to carry than it's worth. It would defeat the purpose of personal transportation. A hoverboard needs to be light enough for users to easily carry and maneuver, yet powerful enough to carry a rider's weight while floating above the ground. Tesla's existing batteries, while highly efficient for electric cars, are relatively heavy due to their size and capacity. For a hoverboard, a much smaller, lighter battery would be required to keep the overall weight of the device manageable. Achieving the right balance between battery power and weight is essential. If the battery is too large and heavy, the hoverboard would be cumbersome and inefficient, undermining the user experience. On the other hand, if the battery is too small, it won't be able to provide the power needed for a stable ride, limiting its functionality. To overcome this issue, Tesla would likely need to create a new type of battery or significantly scale down their existing technology. For example, they could explore newer materials such as solid-state batteries, which have the potential to offer higher energy densities while being lighter and safer than traditional lithium-ion batteries. These advanced battery technologies could be the key to creating a hoverboard that is both lightweight and powerful enough to be practical for everyday use. Another key factor that would determine the practicality of a Tesla hoverboard is its range. People want a hoverboard that they can use for short trips without the constant worry of running out of battery halfway through a ride. While the battery doesn't need to last for hundreds of miles, like an electric car, a decent range is essential for a hoverboard to be useful. Ideally, users would want a hoverboard that can travel between 10 to 20 miles on a single charge, enough for short commutes or fun rides around the neighborhood. To achieve this, the hoverboard would need a battery with an energy capacity sufficient to cover these distances, but not so large that it makes the board too heavy or expensive. Tesla has demonstrated its ability to fine-tune battery capacity to suit the needs of various vehicles, and this expertise could be directly applied to the hoverboard's power requirements. The hoverboard's battery would also need to charge quickly, as most users would prefer not to wait several hours for a full charge. Tesla's supercharger network, which allows for fast charging of electric vehicles, could inspire the development of similar rapid charging solutions for hoverboards, enabling users to get back on the road quickly. Tesla has consistently been at the forefront of battery innovation, both in terms of energy density and cost-effectiveness. The company's work with lithium-ion batteries, as well as its ongoing projects in the development of solid-state batteries and energy storage systems, positions it as a leader in this field. If Tesla were to develop a hoverboard, its expertise in creating high-performance, efficient batteries would be one of the company's most significant advantages. Tesla's ability to innovate and push the boundaries of what's possible with battery technology could lead to the creation of a hoverboard with impressive battery life and performance. However, even with Tesla's capabilities, the challenges of developing a compact, lightweight, and powerful battery for a hoverboard would require a significant investment of time, research, and resources. And then there's the ultimate concern of the public: safety issues. How safe is it to use and ride a hoverboard? Safety concerns and solutions. Again, when considering a Tesla hoverboard, safety becomes one of the most crucial elements to consider. The idea of gliding effortlessly above the ground is exciting, but without proper safety features, the dream of a hoverboard could quickly turn into a nightmare. Traditional hoverboards have faced significant safety issues in the past, from battery fires to stability concerns that led to accidents. Tesla, known for its focus on safety in its electric vehicles, would need to apply the same level of attention to detail when designing a hoverboard to ensure it's safe for daily use. One of the most important safety features for a hoverboard is stability. Riders need to feel secure while using the device, especially since it involves balancing on two wheels or, in the case of a hoverboard, hovering above the ground. Without the proper balance, users can easily fall, causing injury. Tesla could utilize its existing expertise in self-driving and stability control systems from its vehicles to develop an advanced system for the hoverboard. This would help the board maintain balance and ensure the rider remains upright, even on uneven terrain or during sharp turns. Tesla's cars are equipped with autopilot and stability control systems that use sensors, cameras, and software to adjust the vehicle's performance in real time. A similar system could be adapted for the hoverboard, helping the rider maintain stability and avoid sudden falls. The system could automatically adjust the speed and movement of the board, ensuring smooth transitions and a safe experience for the rider, even if they're not an expert. Another significant concern with hoverboards has been the safety of their batteries. Over the years, there have been multiple reports of hoverboards catching fire or exploding due to faulty batteries. This issue is primarily caused by poorly designed or low-quality lithium-ion batteries, which can overheat or malfunction under certain conditions. Tesla, however, has a reputation for creating safe, high-performance batteries in its electric vehicles, and this expertise would be invaluable in designing a hoverboard that doesn't carry these same risks. Tesla could ensure the hoverboard's battery is equipped with advanced thermal management systems to prevent overheating. The company's vehicles feature sophisticated battery management systems, BMS, that monitor the health of each individual cell in the battery, protecting against overcharging, discharging, or temperature extremes. This same technology could be applied to a Tesla hoverboard, ensuring the battery remains safe even during extended use. Additionally, Tesla could focus on using high-quality, durable materials that reduce the risk of battery failure. This might include developing new solid-state batteries or improving the lithium-ion technology to ensure greater safety and longevity. Such improvements would not only increase the performance of the hoverboard, but also eliminate many of the safety concerns associated with traditional hoverboard batteries. Beyond technology, Tesla would also need to implement physical safety features to protect the rider. This could include adding a responsive braking system, ensuring the hoverboard can come to a safe and controlled stop in case of an emergency. A sudden loss of control could be dangerous, so a system that allows the rider to slow down or stop quickly would be essential. Tesla could integrate regenerative braking, a feature used in its electric cars, into the hoverboard, providing smooth deceleration while also recovering energy. Another protective feature could be a secure harness or safety strap to ensure the rider stays attached to the board in case of a sudden jolt or imbalance. Additionally, Tesla could develop a wearable safety system that alerts the rider to any stability or battery issues before they become serious problems. A real-time alert system that communicates with the rider through vibrations or sound could help prevent accidents before they occur. Finally, user safety extends beyond just the physical design of the hoverboard. Tesla could incorporate safety-focused software, such as a speed limiter, to restrict the maximum speed of the hoverboard until the rider has gained enough experience or confidence. This would reduce the likelihood of accidents caused by novice riders who may not have mastered the balance required for faster speeds. A smart app could be developed to connect to the hoverboard, providing riders with real-time data on battery health, speed, and stability. The app could also feature a safety mode that limits the board's speed in certain environments or for beginners. Such smart features would empower users to make safer decisions and enjoy their ride without compromising safety. Hovering heights. One of the most exciting aspects of a potential Tesla hoverboard would be its ability to hover above the ground, offering a futuristic mode of transportation. However, achieving a consistent and stable hover at the right height is not just a matter of technical achievement, it's a complex challenge that requires precise engineering and advanced technology. For a true hoverboard to function, the device must hover a consistent distance above the ground without touching it. The hover height needs to be just enough to give the feeling of floating, but not so high that it compromises stability or safety. If the hoverboard were to hover too high, it might become difficult to control or dangerous, especially when riding over uneven terrain. Conversely, if the hover height is too low, the board might risk scraping the ground or making the rider uncomfortable. This would require Tesla to implement an advanced system that can constantly monitor and adjust the hover height, ensuring it remains optimal for both the rider and the environment. A key component of this would be the sensors embedded in the hoverboard. These sensors would track the distance between the board and the ground, making real-time adjustments to maintain the desired hovering height. This system would need to be incredibly responsive, especially when accounting for factors like changes in the rider's weight or variations in the surface the board is hovering over. To keep the hoverboard balanced and level, Tesla would need to rely on a sophisticated array of sensors that can detect the height and position of the board relative to the ground. These sensors would need to work in conjunction with algorithms that continuously adjust the hoverboard's power and positioning, correcting any potential imbalances. For instance, if the rider shifts their weight, or if the board encounters a bump or dip in the surface, the system would need to make instant adjustments to maintain the hover at the ideal height. Tesla's expertise in autonomous driving technology could play a critical role in this aspect of the hoverboard's design. The company already uses advanced sensors, such as LiDAR, radar, and cameras, in its vehicles to monitor and adjust positioning in real time. Adapting these technologies to a smaller, personal device like a hoverboard could ensure a seamless and stable hovering experience. Another important factor to consider is how the hoverboard would handle different rider weights. A hoverboard needs to adjust its hovering height based on how much the rider weighs, as the added weight could cause the board to dip closer to the ground. Tesla would need to develop algorithms that automatically adjust the board's hover height to maintain stability regardless of the rider's size. Furthermore, environmental factors would play a huge role in how well the hoverboard maintains its height. Rough or uneven surfaces, such as gravel or potholes, would pose a challenge to a hoverboard's ability to float smoothly above the ground. Tesla would need to ensure that the hoverboard system could adapt to these varying conditions, adjusting the height to prevent the board from scraping the surface or losing stability. Let's say all the above-mentioned were solved, but there's still the challenge of weather and terrain. How would Tesla defy these? Environmental factors. For a Tesla hoverboard to become a practical mode of transportation, it would need to be able to function effectively in a variety of weather conditions. Just as electric vehicles face challenges related to weather, a hoverboard would not be immune to the impact of snow, rain, and extreme temperatures. These environmental factors could greatly influence how well the board performs, especially when it comes to power, stability, and safety. Weather conditions are a significant consideration for any transportation device, and this would be especially true for a hoverboard. For example, rain could cause the hoverboard's electrical components to malfunction or short-circuit, potentially posing safety risks to the rider. Tesla would need to ensure that the hoverboard is sealed to prevent water damage and is equipped with durable, weather-resistant materials to protect against rain and moisture. Snow presents an even greater challenge. The hoverboard would need to be able to maintain its stability and hovering capabilities on icy or snowy surfaces, which could be slippery and unpredictable. Additionally, the cold temperatures could affect battery performance, reducing the range and overall power of the hoverboard. Tesla would need to create a system that keeps the board functional in these harsh conditions, potentially integrating temperature-sensitive components or enhanced battery management to ensure a consistent performance. Extreme heat could also be a factor in the hoverboard's performance. Just as heat can affect the battery life of electric vehicles, the same could happen with a hoverboard. High temperatures could lead to overheating, causing the board to slow down or even shut off to prevent damage. This would require Tesla to design the hoverboard with temperature regulation systems to prevent heat buildup, ensuring it continues to function smoothly in warmer climates. Another environmental challenge for the Tesla hoverboard would be the terrain it operates on. For a hoverboard to hover above the ground, the surface underneath must be relatively flat and free of obstacles. In real-world conditions, however, surfaces are often uneven, with potholes, cracks, and debris. This makes it difficult for a hoverboard to maintain a smooth hover, as it would be prone to instability or contact with the ground, particularly on rough terrain. Tesla would need to consider these surface conditions carefully when designing a hoverboard. It would need to create a system that can adapt to small irregularities in the ground, perhaps by adjusting the height or power distribution to maintain stability. In crowded areas, where people and objects may be in close proximity, the hoverboard's sensors would need to be finely tuned to avoid collisions while maintaining a safe hover height. Will Musk be able to show the world a fully functioning Tesla hoverboard in the future? Thanks for watching the video. Subscribe for more.